Hello, this is an industrial instrument and sensor 7 module. Now we are doing skill test number 3. The work order they received stated that the exhaust fans keep running non-stop and the foggers doesn't seem like working. So before I do anything, I will try to go to field site to have a look. So I observe that all the heater banks are turning on and all the exhaust fans are running. As we know, the temperature is 16 degrees considered low, so exhaust fans are not supposed to run because the only time it runs because the room temperature is high, not room temperature is low. So when looking at the fogger, okay, this fogger is a device that produces fog or mist. It will only produce this fog when the humidity is low or dry or the temperature is too low. Okay, so the water say that the fogger doesn't seem like working and the exhaust fan keep running. So let's see what is wrong with that. So if we have the PLC access, we can view the PLC logic diagram to find the humidity and temperature set point and to see any wrong within the system. If let's say we do not have the PLC access, we have to use a schematic drawing to identify the problem. So after visiting the field site, I will go to the control panel and try to find any anomaly by looking at the lighting. Okay, here I see there's a low temperature alarm, which is true because the local temperature now is 16 degrees Celsius, considered low. So when the temperature is low, what happens is the foggers should turn on to produce fog or mist, and the heater bank should turn on too, but the exhaust fan are not supposed to turn on. As for the humidity, I'm not very sure because humidity usually will control the foggers. It will have a direct control because when the humidity is low, that means it is very dry. We need the foggers to turn on to produce fog so that it can increase the humidity and vice versa. At the moment, I do not know the humidity set point, although I can use a PLC logic diagram to check it. But as I say, sometimes we are not living in the ideal world. We may not have the PLC access to check the set point. So what we can do is we can, based on the drawing that we have, and try to identify from the problem from the drawing. Okay, so now we can see that the humidity suspect to have the issue. Of course, it can be the issue from the RTD sensor or the humidity transducer. Okay, the RTD temperature looks like okay because it gives you because it reaches 16 degrees. It's a very low temperature alarm, and you're able to trigger the low temperature alarm, showing that this temperature maybe is the correct one. Okay, now the problem is, okay, the humidity maybe is a bit low, but the foggers did not turn on. Okay, it maybe give the false signal to the PLC analog input. So that's why the foggers did not turn on. Maybe the PLC think the humidity is high, fogger will not turn on and the exhaust fan will turn on. Okay, so based on the circuit, we can suspect the problem may be due to the humidity sensor. So we can always measure the voltage between the PLC channel load. Okay, this is a PLC input channel load. We measure the voltage at the analog input module number 3, channel 1. We measure the voltage between 1V and 1R. We put the multimeter black probe at the negative voltage, okay, terminal. Or we can put here because this point actually connected to the negative voltage terminal. Okay, so by looking at the wiring diagram, we know that for PLC analog input, okay, module number 3, channel 1, we can measure the voltage between 1V to 1R or TB25 to TB26. This TB25 to TB26. Okay, 6 connected to 4, 4 connected to 2, finally connected to DCS, DC power supply, negative voltage. Okay, so we will measure TB256 here, TB25 and 6. So we open the control panel. Okay, and we take out our multimeter and then set to DC voltage, measure TB25 and TB26. Okay, now it reads 5.37 volt, which is wrong. Why? Because the DC voltage signal at the PLC analog input side must be always from the 1 volt to 5 volt. It cannot be more than 5 volt nor lesser than 1 volt. Okay, the instrument may send a 4 to 20 milliampere signal to the PLC analog input. At the PLC analog input, this analog current will be converted to analog voltage of 1 to 5 volt. Subsequently, will be converted from analog voltage to digital value through the AC/DC converter. Okay, so more than 5 volt meaning more than 100% of humidity. So the PLC actually detected this 100%, this 5.37 volt as more than 100% humidity. Thus, it will not turn on the fogger's unit. At the same time, it will turn on all the exhaust fan to suck out all the heat from the greenhouse room. Okay, so what is wrong with that? It can be due to the problem of the PLC analog input channel, or it can be due to the problem of the transducer sensor, of the humidity transducer. Okay, maybe the transducer having open circuit or loose termination. Okay, so when this happens, okay, when there's an open circuit or loose termination, it will be having the maximum voltage drop at the humidity transducer. Thus, it will give you higher humidity reading at the PLC side. So what the way to do it, to check it, is to measure the resistance, but resistance cannot be measured live, so we had to switch off the power supply and then perform the lockout takeout. Okay, switch off the power supply and then perform the lockout takeout. Okay, then we can measure the resistance of the load across the load, and with one end open. Okay, so this is TB25 and TB26, TB25. And we measure the resistance. TB25 and TB26. Oh, sorry. Okay, TB25 and TB26. It looks like the resistance is okay, so there's no open circuit. So it can be this fault, it can be due to the analog input channel, or it can be due to the transducer of the humidity sensor. So let's normalize the circuit, put back the wiring. So as we measure the voltage just now, we find that the voltage at the PLC side is very high, but the actual local read, the actual reading at the humidity side, the local reading, the local reading at the humidity side reads about 55%. So most likely the humidity sensor is faulty. They give a false signal, whether you need to calibrate the output signal or you have to change the humidity sensor. Okay, let's go to the field side and then change the humidity transducer. Okay, you see the local reading of the humidity sensor reads 55%. However, okay, the field side at the control panel side, it gives more than 5 volt. It should give about maybe about 3.2 or 3.5 volt instead of 5.3 volt. So it means this output signal having issue. Maybe the transducer give the wrong output signal. Instead of about 12 point something milliampere that correspond to about 3.2 volt, it gives you 5.3 volt. So either we need to calibrate the output, that means do the zero span, or we change the humidity sensor. However, this software is unable to perform zero and span calibration, so I have no choice. I have to replace the whole transducer. Okay, then I go back to the control panel. Okay, then I remove the lockout takeout. Turn on the power supply and measure the voltage one more time, the DC voltage. Terminal 2, point number 5, TB2 6. Now it gives you 3.2 volt, which is corresponds to about 55%. So now we have successfully done the troubleshooting.